All right, so we're in section 4.7. So sometimes we are given problems where we don't have two separate figures. Sometimes our figures are overlapping. And we have to figure out what pieces of information are important, what piece of information that we need. So in general, what you need to do when we have overlapping triangles is we need to figure out what information we have or what triangles that we're looking at. So figure out which triangles are important. And then we need to figure out what pieces they share. Might be a segment, it might be an angle, something that when our triangles overlap, there's some piece of information that they might share. It can be helpful to redraw a picture with separate triangles. So I just want to go through a few examples. This first one, we just want to pick out what the triangles share. So my example, my drawing is going to look like this. So there's one triangle, and then there's the other triangle that overlaps. And I'm going to draw or name this triangle, just name these vertices, X, Y, Z, and W. And the question is, what do triangle XWZ and triangle WXY share? So this problem tells us which triangles are important. So I'm going to highlight those. XWZ. XWZ. There's one triangle. The other triangle is WXY. So WXWZ, W. Actually, I highlighted WXY first. XWZ is going to be this red triangle. There's the other triangle. And the question asks us, what thing do those two triangles share? And it might be helpful to redraw them as separate triangles. I'll just draw them a little smaller here. So there's one that is XWZ. That's the one I highlighted in red. Oops, undo that. And that. And here is the other one. And that is WXY. And that was the one I highlighted in blue. So what do those two things have in common? Yeah? Segment XW. We can see here on this triangle we have a segment XW here, and here we have a segment XW. Here we can see that we highlighted blue and red along segment XW. So the segment that they share is segment XW. And if we were doing some kind of proof that had to do with these two triangles, You might need to say at some point that XW is congruent to itself by the reflexive property. But identifying which triangles are important and then figuring out which parts they share, that's the key. And sometimes we'll have a drawing like this where it looks like the problem has to do with overlapping triangles. But when we identify the parts that are important, the problem is not about overlapping triangles. So figuring out what the pieces are that we're looking at is an important first step. So I just want to go through a couple of proofs that use this kind of idea. So here's our picture for the first one. Looks similar to the picture we just drew, just a slightly different configuration. All right, so here we're given that segment RT is congruent to segment US. And angle URS and angle TSR are right angles. We want to prove that angle T is congruent to angle U. Now just if we were to try to mark these figures with what it says here, RT is congruent to US. Well, we have this segment and this segment. It would be hard to mark them. Angle URS, this is a 90-degree angle. We could mark that, but things kind of end up on top of each other. So I'm going to highlight here again. So RT is congruent to US. And it says angle URS and angle TSR are right angles. So based on that information, I'm going to guess we are looking at, or we're going to be working with that triangle and that triangle. Because we want to show that angle T and angle U are congruent. So based on the information they give us, I think the problem is about those two triangles. So let me redraw those. And then we can mark our congruent pieces. So there's a new drawing. That is our U and S, and this is our ST. All right, so we know that RT is congruent to US. Angle URS and TSR are right angles. Well, we have right triangles there. My guess is this proof is going to have to do with hypotenuse leg. We need to show that the triangles are congruent, and then once we know the triangles are congruent, we can say the parts are congruent. We can use CPCTC. Usually when we have to show two parts of triangles are congruent, we have to show the triangles congruent first, and then use CPCTC. So let's do that. I'm just going to write my proof here. I'm not going to rewrite the given information, so that's all given. We have that given. Is there a piece of something that those two triangles share? Yeah. Segment RS. They overlap here on segment RS. So I can say that segment RS is congruent to itself by the reflexive property. Do we have enough information now to say the triangles are congruent? We have a right triangle, we have a hypotenuse, we have a leg. So we can say the triangles are congruent. I can say triangle URS is congruent to triangle. Angle U has to match with angle T. That's what we want. USR. And that would be by hypotenuse leg. And now I can say that angle T is congruent to angle U by CP/CTC. Corresponding parts of congruent triangles are congruent. And if you said at this point those angles are congruent because the triangles are congruent, that's fine also. It means the same thing, really. Yeah.
Do you mean that triangle URS is congruent to the triangle TSR?
Yes, thank you. I said it when but I wrote the wrong thing. All right, questions there? Okay, sometimes we have to be careful because the problem might look like it has to do with overlapping triangles, but it doesn't really. So that's why it's important to identify the triangles that we're working with, that we're interested in order to solve the problem. So here's my setup here. So it looks like it might have something to do with overlapping triangles. We have some triangles that overlap. I'm going to call this B, D, that point E, and C and A. All right, and we're given that segment AE is congruent to segment BE. And angle C is congruent to angle D. And we want to prove that segment BD is congruent to segment AC. So let's figure out what triangles are important. Excuse me. All right, first it says segment AE is congruent to segment BE. So I'm going to mark those two. And then it says angle C is congruent to angle D. So we know those are congruent. We know that those two angles are congruent. And we want to prove that BD is congruent to segment AC. Well, based on the information, and here we have this angle, based on that information, I would say what's important is that triangle and that triangle. And we don't need this other segment over here, isn't even important. We don't have overlapping triangles. We do have overlapping triangles, but the overlapping triangles aren't the important ones. So what I want to do is show that the red triangle is congruent to the blue triangle, and then use CP/CTC to say that those segments are congruent. So let's do that. And this is pretty easy one. Hopefully some of you may see what we're doing already. So the given, I'm not going to rewrite those givens. All right, so for those two triangles, the red one and the blue one, is there another piece of information? We need three pieces. We have two. Is there a third piece of information we can figure out? Yeah? What's that? Yeah, we have a vertical angle. We have vertical angles here. That's a pair of vertical angles. So we can say that angle BED is congruent to angle AEC. And they're vertical angles. Well, now we have angle, angle side, and angle, angle side. So I can say triangle AEC is congruent to triangle BED by angle, angle side. And then because of CP/CTC, I can say BD is congruent to AC by CP/CTC. So for this particular problem, it looked like we had overlapping triangles, but the overlapping triangles weren't the ones that were important for the information that we had and that we were interested in. Okay, questions? All right.